In this video, I want us to look at a question from chapter 19 of the Year 12 textbook. It's exercise 19.4 and question 13. As I go through this, I'm not intending to give you every little detail. I want you to work those out for yourself. I'm going to give you some pointers as to how to proceed. If at some point you suddenly think, oh, I understand that now, please pause the video and finish it for yourself rather than listening to me anymore. Okay, a particle P moves along the straight line AB. Midpoint, so it's not just a random point, but this is the middle of the line. And we have the velocity time graph for P shown here. Now, I think it'd be quite helpful to be able to draw on this. So let's have a look. I think the first thing to say is that this 20 seconds, it just shouldn't be there. That's a typo. If that's what's caused you the bother, then pause the video now, lose that 20, and try the question again. If that wasn't what was bothering you, then proceed as follows. I think it'd be helpful to label some of these parts of the graph. The particle starts at rest, 0 meters per second, from a point X, from this point X halfway between A and B. I think it'd be quite helpful just to label X there. It moves towards A, it comes to rest at the A when t equals 3. I think it would be helpful to label the graph like that. And then later on, after being instantaneously at rest when t equals 3, as I've marked, the particle starts to move towards B, etc., etc., and comes to rest at B. So 0 meters per second, the particle is now at B. So what it's done is, it started at X, it started travelling towards here, it's taken 3 seconds to get there, and then it's taken some more time to get from A to B. It would be worthwhile, I think, acknowledging which direction is positive. They've given velocity, which is a vector, it's got direction involved in it. They've given velocity a negative value as it travels from X to A. So they've said that going left is negative. So I'm just going to make a note up here that I'm going to use to the right as positive, to the left as negative, whenever I'm talking about the velocity. Like I said, this 20 seconds that they've put here, that shouldn't be there. It's a mistake. Okay, find the distance AX. Now, you should know that the distance between the line and the horizontal axis on a velocity time graph is the distance that's been travelled. That's because we have meters per second multiplied by seconds, which combine to give us meters. This area here and this area here both represent distances. And we've been told to find the distance between A and X, so this distance in here. So I would suggest to you that that's very easy. It's just the area of a triangle. It works out at 7.5 meters. You need to show the working properly. Now, after being instantaneously at rest, the particle starts to move towards B. It takes 15 seconds to travel from A to B. And so I can say that. That's where the 20 was just wrong. And it comes to rest at B. For the first 2 seconds of this stage, so we're now up to the 5-second mark, P is accelerating at 0.6 meters per second squared. And so here, you're going to use the knowledge that the final velocity is equal to the initial velocity plus the acceleration times the time. That is going to give you a final velocity for this part of the journey. Again, show it properly, but it works out at 1.2 meters per second. So this is 1.2 meters per second. Find t. t being it reaches a velocity v, which we've said is 1.2 meters per second, which it keeps for t seconds. So from here to here, that is t seconds. And we're supposed to find t. This is the difficult part of the question, and I don't want to give you every last detail on it. But remember what we said. This is the distance between A and B. This area is the distance. X is the midpoint of AB. We've already worked out the distance from A to X. So we should be very easily able to work out the distance from A to B if we know what A to X is. And we know that this area is the same thing as the distance, and it's equal to the area of a trapezium. So I would suggest to you that it's possible to substitute certain things into here. I'm not going to fill them all in for you, but this little length across the top is capital T. You know the length of the base. We've worked out the height of the trapezium in part 2. And like I say, the distance from A to B isn't complicated if you realise that X is the midpoint of that line. So I'm not going to tell you what to put in there. But you solve that equation and you will discover what T is. Once you know what T is, find the deceleration. So it's talking about the deceleration that's happening here. You're going to use this formula again. The final velocity is 0 as it comes to rest. The initial velocity is 1.2 meters per second. Once you know what t is, then you know how long this part of the journey lasts for, and so you can then work out the deceleration. Those are the pointers that I'm willing to give for this question. The rest of it now is up to you.